Good morning, children. Today we'll discuss about the applications of logarithm. Before that, let me revise you the properties of logarithms. So first, properties of logarithms. I have explained you the derivations of them. So what are the properties of logarithm? The first one is log x base a plus log y base a can be written as log xy base a, means the addition in the logarithms can be shown as multiplication, log xy base a. Now this is called as the first law of property. The example is, suppose you have log 7 base a plus log 2 base a can be written as log 7 into 4 base a, which in turn can be written as log 28 base a. This is how we are going to write. Similarly, the second law of property of logarithm, second property is log x base a minus log y base a can be written as log x by y base a, log x by y base a. Now how will you show with an example? Log 15 base 10 minus log 4 base 10, log 3 base 10 or log 2 base 10 can be written as log 15 by 2 base 10. This is how you will represent the given number. Means the subtraction is shown as division in the symbol. Here the multiplication, the addition can be shown as multiplication here in this. Next one, coming to the third property is log exponential form, log x to the power of m base a can be written as m log x base a. For that, the example is, suppose you are given log 2 to the power of 4 base 10 can be written as 4 log 2 base 10, means that exponent which you got it here can be taken as 4 log 2 base 10 as a coefficient of it. So which becomes 4 log 2 base 10. So these are the three basic properties in the logarithms which I have explained you earlier, and now I have revised them now. Coming to this next, here we have the application of it. You have to write that as, say, in your sums you are having log 2. If nothing is given, we have to take the 10 as a base. So log 2 base 10 plus log 5 base 10. How shall we write this now? Log 2 base 10 plus log 5 base 10 can be written as log 2 into 5 base 10, which in turn can be written as log 10 base 10. Now this is your first question. Now the second question is log 16 base 10 minus log 2 base 10. Whenever you are given a subtraction symbol, that can be taken in the division symbol. So here we are going to write it as log 16 by 2 base 10, which in turn can be written as log 8 base 10. 2 and 16 can be cancelled by 8 times. So log 8 base 10, the value is log 8 base 10. Now if you want to write the next one, suppose the third question is 2 log 3 minus 3 log 2. This is what is the next one. Suppose you have 2 log 3 minus 3 log 2. So this first you have to take this coefficient to the numerator. Then it becomes what? Log 3 square. Here this 2 occupies the place of exponent. Base is as usually 10 minus this, here you are going to write it as log 2 cube base 10. Here the coefficient is 3, therefore it goes to the exponent part. So log 3 square base 10 minus log 2 cube base 10. Now again you can simplify it. Log 9 base 10 minus log 8 base 10. 2 cube is equal to 8 and 3 square is equal to 9. Still there is a negative number. So still you can write it as log 9 by 8 base 10. You can simplify it and write this sum as log 9 by 8 base 10. Here we have used two properties. The third property, first we have used, what is third property? Log x power m is equal to m log x base a. Means exponent will be occupying the place of coefficient, or coefficient will be occupying the place of an exponent. So here 2 log 3 base 10 was written as log 3 square base 10, and 3 log 2 was written as log 2 cube base 10, and 3 square is equal equal to 9, therefore log 9 base 10 minus log 8 base 10. Still we have the next second property was used here. Now log 9 by 8 base 10. This is what is a single logarithm for it. Now coming to the next one, fourth question here you have as log 243 plus log 1. This is given to you. So as they are simple. First do the prime factorization for 243. 3 here 81 times. If you do like this, you are going to get it as 3 to the power of 5, means 243 is equal to 3 to the power of 5. So here you can write it as log 3 to the power of 5 base 10 plus log 1 base 10. This is how you can write it. Now here this is the first property we have used, and now take the third property. Exponent will be occupying the place of the first one with new coefficient. So it is 5 log 3 base 10 plus log 1 base 10. This is what. Now it is equal to 5 log 3 base 10 plus log 1 base 10. Log 1 to any base is equal to, that is also a property which I have explained you, that log 1 to any base is equal to 0. If you want to find out the value, it's always 0. Now here 5 log 3 plus is there, so we write it as multiplication, which becomes what? Again the same only, 5 log 3 base 10, and log 1 to base 10 is always 0. Log 1 to any base, not only 10, any base will be equal to 0. So here the value is 5 log 3 base 10. Ultimately we can write it as 5 log 3 base 10. See children, if you multiply or 2, you are going to get the same thing only, nothing else. Though you want to use the first law of application, you are going to get it as 5 log 3 base 10 only. I think you all understood now how to make it as a single logarithm. Expanded form is given and you are asked to write it in a single logarithm. Now in the next one, here your form is given as a single logarithm, means single logarithm is given and you have to expand it. How do you expand? Suppose you want to expand log 1000. Remember, always whenever the base is not given to you, you have to assume that as 1. So for 1000, whatever the number is given, do the prime factorization. Prime factorization, take only the prime numbers. Don't take the composite numbers. Take only the prime numbers. So take here 2, it becomes 500. Again take 2, it is 250. Again take 2, it is 125. Take 5, it is 25, and 5, again 5, 5 and 5. So here you can write it as simply log 2 into 2 cube into 5 cube. This is what is the expansion form of it, and log 10. So here again into can be written in the form of addition. So here you have to write it as log 2 cube base 10 plus log 5 cube base 10 here. This multiplication is converted as addition now. Now again the third law is to be used. Take that exponent to the place of coefficient. It is 3 log 2 base 10 plus 3 log 5 base 10. Since 3 is common in both, you can take 3 common. 3 into log, tell me, log 2 plus log 5. Both the bases are 10. 3 log 2 base 10 plus 3 log 5 base 10. Since 3 is common in both, 3 we have taken common, log 2 base 10 plus log 5 base 10. This is the expanded form of log 1000. First we have to do the prime factorization for it, write it in the exponential form, and that exponential form may be simplified. If they are equal, we are going to take common. If they are not equal, we are not going to take it common. We will be leaving in this step itself. Now coming to the next one here, in another expanded form, you have expand log 128 by 625. This is 1. So here you are given 128 by 625. Again the same process, whether you are given one number or the fraction, do the prime factorization for both the numerator and denominator separately. Fraction is given. So 2 here 64 times divisible, 2 here 32 times it is divisible. Take 2, 16 times divisible, 2 is 8 times divisible, 2 here 4 times divisible, 2 2s and 2 1s. Means what? Log 1, first you have to write it as log 128 base 10 minus log 625 base 10, because this negative fraction can be written in the form of log x by y, can be written as log x base a minus log y base a. So here 128 base 10 minus log 625 base 10. So this log 128 base 10 can be written as log 2 to the power of 7 base 10, because 1, 2, 3, 4, 5, 6, 7. So it is 2 to the power of 7 base 10 minus, do the prime factorization similarly for 625. You are going to get it as 6 to 5 to the power of 4. So this we will be writing it as log 5 to the power of 4 base 10. Now you will convert it as 7 log 2 base 10 minus 4 log 5 base 10. I think now you understood the third property we are using. The exponent was taken as a coefficient. So wrote it as 7 log 2 base 10 minus 4 log 5 base 10. This is how you have to expand the given number. Now another question in the variables. Now you are given as log x square y cube z to the power of 4. Here what does it mean? Log is there, x square means what? X square means x into x, y is having cube and z is to the power of 4. Now they are in the multiplication mode. Multiplication mode can be written as addition mode. So here first you have to write it as log x square plus log y cube plus log z to the power of 4. First instance the multiplication can be shown with a addition. Now take the addition, now take base only. If nothing is given, we will be taking the base as 10. Now take this exponents to your coefficient form. It becomes 2 log x base 10 plus 3 log y base 10 plus 4 log z base 10. This is how you have to expand the given form. First change it in the form of logarithms with addition symbol, and then generally means you have to write the third, apply the third property and write. Let me show another example. Log root over x cube by y to the power of 2. See, root means all of you know that it is to the power of 1 by 2. Log, it is to, once again I am explaining, log x square y cube z to the power of 4. First expand it, and then 2 log x 10 base 10 plus 3 log y base 10 plus 4 log z base 10. This is how you have to write it. Now coming to the next one, log x cube by y square root over is there for both the numerator and denominator, which in turn you can write it as log x cube by y square whole to the power of 1 by 2. All of you know that it is a square root. 9th standard it was explained to you already. It is a second order surd.